Section 1. Understanding the Universe. Chapter 1. Our Place in the Universe. Lesson 1. The Vastness of the Universe. Earth, our home, is one of the 8 traditional planets that orbit our Sun. From a distance, our home looks like nothing more than a pale blue dot, as the late astrophysicist Carl Sagan once acclaimed. We are not visible from such a distance, nor are our monuments, skyscrapers, satellites, or metropolises. We are blurred in the details of a relatively small space rock. This home of ours is 93 million miles from the most prominent thing in our skies, the Sun. Our Sun is a star like all the others in the night sky, and it is one of the 200 billion stars in our Milky Way galaxy. Our next nearest galactic neighbor, the Andromeda Galaxy, is 2.5 million light-years away, a unit of measurement used in astronomy that we will discuss later, but in miles, this would be 150 octillion miles. This number might mean nothing to you since it is unfathomably large, but, in a frail attempt to put it into perspective, a measuring tape from here to the Andromeda Galaxy would wrap around the Earth 600 trillion times or go from the Sun to Pluto 4 billion times. These distances are incredible, and that is only to the next nearest galaxy, but there are 100 billion other galaxies out there, all at unfathomable distances. Current estimates by cosmologists, the scientists who study the universe on a grand scale, tell us that the universe is 93 billion light-years across. This distance is tens of thousands of times larger than the distance to Andromeda. Unfortunately, this many light-years becomes nearly impossible to talk about in units we are familiar with. To put it into perspective, the farthest humanity has spread is the Voyager 1 spacecraft that is still moving away from the Sun at 38,000 miles per hour. The Voyager 1 has reached about 3.5 billion miles, or 0.0006 light-years. This is our farthest reach into the vastness of the cosmos, and we have yet to even make an impression in comparison to the scale of the universe. Lesson 2. The Cosmological Principle. There is a vast and mostly unexplored universe out there for us to study, observe, and learn from. For millennia, humans have been trying to explain the cosmos. In ancient days, myths and legends depicted the formation of the universe and how everything in it works. Still, scientists have worked hard to demystify these topics by replacing myths and legends with laws and constants. Today, we understand that these physical laws govern the universe, and we are but witnesses to how it works. Even as mere witnesses, we have been able to put together countless books to describe the universe's ways. We have written countless laws to describe motion and energy and thermodynamics and just about everything else. Using our laws, we have accurately predicted everything from the heating of our lunch in a microwave to the motions of the planets around the Sun. Our laws are not infallible and are continuously checked and adjusted when we prove parts of them wrong or incomplete, but they are nonetheless the best tools we have to predict and describe how things work. The cosmological principle is a fundamental concept in astronomy, as it tells us that these physical laws of the universe are unchanging no matter where you are. As a lighthearted example, the cosmological principle allows us to assume that aliens in a distant galaxy would be able to use microwaves to heat their lunches while they are hard at work in their offices just like we can. In a more formal explanation, astronomers use this cosmological principle to understand that planets around distant stars orbit in the same manner. Stars in distant galaxies produce energy the same way our Sun does. This concept might seem like an obvious one, but I challenge you not to underestimate its importance. After all, if we could not apply our physical laws elsewhere, we would be left determining new laws for every system we discovered, an overwhelming task. Lesson 3. An ancient Earth-centered view. Witnessing the stars and planets moving across the night sky was not enough for the Greeks. They wanted to understand the universe they were a part of. Aristotle, a great Greek philosopher, gave the Greeks a model of the universe that would live on in mainstream beliefs for well over 1,000 years. His model is simple to explain and easy to like, and thus, it was adopted by millions. In around the 4th century BCE, Aristotle proposed that the Earth was a stationary sphere sitting in the center of the universe with the Moon, the Sun, the 5 visible planets, and all the stars in the night sky orbiting around it in circular motions. This view, known as the geocentric view, was supported by the fact that each day the Sun, Moon, and planets do appear to orbit around us as they move through our sky, and by the fact that we don't feel the Earth's motion. We know now that these motions across our sky are actually due to the Earth rotating and turning away from the objects, and that we don't feel the planet's motion for the same reason we don't feel the motion in a car moving at a constant speed, because we only feel changes in motion. At the time, this model made sense and was relatively unquestioned by the public, though some scientists and philosophers took issue with it over time. As ancient astronomers looked at a planet one night and took note of its position, and then checked for the planet the next night at the same time, they noticed that the planet would almost always appear to have moved westward in the sky. However, sometimes, the planets turned around and would appear to have moved in the opposite direction briefly. This brief but relatively common backward motion of the planets, known as retrograde motion, was unexplainable in the geocentric model and eventually forced astronomers to seek a better explanation. Ancient geocentric model. Lesson 4. The rise of a sun-centered view. Aristotle's geocentric model lived on in the world for over 1,000 years until it was challenged by a series of revolutionary astronomers starting in the 1500s. Aristotle's model was well liked as it was easy to explain, and it put us into the center of the universe. It went along with the egotistic belief that the entire universe was put here for us and that our place in it must be unique. A book titled, On the Revolutions of the Celestial Spheres, was written by a Polish astronomer named Nicolaus Copernicus in 1543. It is one of the first recorded proposals for a sun-centered universe in which all the planets orbited the Sun in circular motions. This view, which is known as the heliocentric model, was directly against the widely accepted geocentric view at the time and was therefore not well received until substantial evidence came about in the following century. At the start of the 17th century, few astronomers and scientists believed in Copernicus' proposed view. One such astronomer was a young German named Johannes Kepler, who would publish 3 planetary motion laws, detailing how the planets orbit the Sun in ellipses or ovals. Soon after, Galileo Galilei became the first person to ever look at the sky with a telescope, and he made a note of moons that orbited Jupiter, proving that not everything orbits the Earth. Even though the evidence against the geocentric view and the heliocentric view was building up, it was not until Sir Isaac Newton published his laws of motion and gravity near the end of the 1600s that the heliocentric view was widely accepted. Part of this turning point was Newton's explanation of gravity, which he defined as a mutually attractive force between any objects with mass. This explained why we were not floating off of the Earth and why the planets all orbit the Sun, and it would become the cornerstone of classical mechanics. Chapter Review. The cosmological principle is the idea that we are not in a unique place in the universe. We expect that the laws that govern nature here do the same everywhere in the universe. The geocentric perspective was the ancient perspective that the world was stationary and in the center of the universe and that all things in the night sky orbited around us. Retrograde motion is one of the geocentric perspective's major flaws, believing in the apparent backward motion of planets in their night-to-night positions. Nicolaus Copernicus was one of the first people to propose a sun-centered perspective in a book titled, On the Revolutions of the Celestial Spheres, in 1543, more than 1,000 years after Aristotle proposed the geocentric perspective. The heliocentric perspective is the sun-centered perspective that Copernicus proposed, and other revolutionary scientists provided support and evidence for.